Hey everyone, welcome to Software Engineering Mini Lectures, episode number 5. My name is Adam Corbin and I'll be going over design and reviews in this lecture. So I'll just go and touch about things that I have worked on in my experiences in design and really model-based design. Something that in aviation, doing model-based design and especially the higher level critical applications have some challenges because it just adds an extra complexity layer into it, and I think that has a little bit more scrutiny because in sometimes model-based design they have some auto generation of code and stuff like that. So with the people I've talked to that have done through model-based design and other companies, they have found that it's actually been pretty helpful just within the aviation industry, that it just takes a little bit more extra things that we need to do. But basically, so for design, some of the things that I try to do and think about is really in any design, whether it's model-based design or not, you really want to think end-to-end, which specifically includes testing, especially in aviation. Testing is almost half of the work, or if not more, just to do all of the extra things that need to be, and sometimes you need to be testing like all the different paths, and even sometimes in like level A projects you need to test all the combinations of a specific path. I think it's MDC. Yeah, I don't remember the acronym, but basically every single combination, which can be extremely intensive. So yeah, so basically the reason why I say you want to think about the testing aspect when you do your design is because you might come up with an elegant design, but it becomes very difficult to test. And especially when you get down the road, that testing cost can increase significantly relative to if you were thinking about the testing as long as you were doing the design. It should help out. I know in any case, usually it's not going to be perfect, so you definitely have to weigh what your positives and negatives based off the design versus testing. But I'm just want to highlight that you want to think about testing up front when you do your design, because if you think about it afterwards, most likely you're going to be thinking, oh wow, I could have done this a little bit better. So even coming up with some prototypes, thinking about design and thinking about how you can do your tests at the same time will be very helpful. So also when you do think about your design, think about ways that potentially might change or to add on or to be able to basically scale. So especially when you're working on a large project and you think about something that maybe is like an event driven thing and you're going to be adding multiple events, and how can you be able to handle that, especially if you're going to be creating a product line to be able to have multiple events across customers. How can you be able to architect it in a way that you can reuse as much code as possible? So definitely think scalable when you think about design. Sometimes if you're working on a smaller project, it might not be as important, but when you're working on a very large project with many people, definitely want to be able to think about how this project could even expanding to be able to support multiple users. So that's something to think about. Another thing too, as part of design, is change impact analysis, really. And so this comes down to when you already have a product in the field and you come with a problem and you need to fix this problem, there's this concept called change impact analysis, which really goes into, when I change this certain thing, do I need to retest all these extra things? Because testing can be very expensive. So this is a smart way of being able to isolate your changes and isolate what you need to retest. So the concept really starts from looking at a requirement and saying, well, okay, what test do I need? What test does this requirement relate to? Do I need to expand any tests that it might impact? So really doing that change impact analysis, starting from the either if it's a high level requirement or a system requirement. If system requirement, then you potentially could be testing a lot of things, but it's a lower level requirement. Maybe there's only X number of tests that you need to test. So just think about that too, and how you set up your design to not have a lot of dependencies on the lower level. Try to isolate things, because there are very many low level layers in the system that could potentially be affected when you have these type of things. So it's a smart way of doing it. So and now I'm going to go into a couple examples that I've worked with that either they were potentially not, they ended up being learning lessons for sure. So one thing that I want to talk about is this systematic application design language, which we call SADL. It's something that the GE's Research Center, and I'm going to go pull it up right here. So this is like their documentation language. Basically, it was a way to represent requirements using what we call an ontology, which is basically a dictionary of all these different key terms, and they call it like a data model. So in this data model, there's basically you can create, you could think of it as creating data structures that have like this is a class and it contains these little properties, and so you can create classes of classes, and basically once you build up that data model, then you can actually create your specific requirements. So and these requirements, they have some in a way to be able to test, kind of like making sure that you have cover all your corner cases and stuff like that. So it's a nice way of being able to write requirements and verify your requirements without actually creating any test cases. And what's interesting about this is the concept was to be able to actually create and generate test cases. And then once that was done, it was going to be able to create and generate test procedures. So it was a very interesting concept that has been proven to work in smaller cases that were very Boolean logic, I would say, that aren't super complex. So we did this especially for the lower level requirements for the flight management system program that I work on, and it ended up just being very complex and really wasn't scalable to what we were trying to do. And I think we were definitely pushing the bounds on this. So this is definitely a way of doing model-based design from a requirement standpoint. It did not auto-generate any code, but it did supposedly supposed to generate test cases, test procedures. We did do a good attempt run, maybe like a year and a half. Ended up not really working the way we wanted to. I think also too, this is an interesting thing that when you do try these new things, I think having an end-to-end full example, working example with creating test cases and test procedures is very helpful. And at the time, they didn't really have that ready and available for us. So having end-to-end capability of tools, and it was actually still working in development too. So if you're running on a program, I highly recommend not picking a tool that's in development, because you might be hamstrung by the limitations of that tool. So definitely work on proven tools. So we have another lecture on tools and stuff like that, so I won't go too much into that. So yeah, so that was something that was really interesting, because I do like how we did create the requirements and the structure, and it was very clean and easy to follow. See if I can. I remember. Let's see. Yeah, it doesn't have the actual examples here, but yeah, so it ran, it did an interesting thing, and we did find some things where it has been successful is I think in the GE engines area, where it was level A, and it generated test cases and test procedures when it's really like super simple, like when this thing happens, it does this. Whereas in for FMS, it's very complex, where you have like well, when you have these like combinations of different waypoints and when you're in a certain area, it can do certain things, and it was just really difficult to represent that. And then I had the concept of trying to be able to have multiple requirements linked together, and it just didn't end up working very well to what you wanted to. So we kind of failed on that, but it was a learning experience, and I think it was a good thing. So I'm going to go into the next thing. Next example is something that we tried to do. Instead of doing low-level text-based requirements, we used this tool called Omelette, which actually was pretty nice to create kind of like flow diagrams and decision diagrams. And so it was actually really nice to look at that, and you can see it and follow it pretty easily versus like a text base. And so this was something that was originally looked really nice, but it was something that I missed. And so one of my first bullet points is thinking, including test when we're doing this, and it was something that was really missed that I didn't see, and that was thinking about test when we were doing these low-level designs in the experimentations of doing these low-level designs was really good for simple things, but when we started getting into really complex low-level designs that had maybe it could have been like 15 to 30 different decision points, when we created test cases and tried to link to these low-level design models, it was really difficult to know what test case tested what maybe node in the design, because there wasn't a easy way to pinpoint to those designs. Maybe there was a way we could have identified each node, but it ended up becoming a little bit more complex than it was for testing purposes. So that's something that we did roll back, and we ended up going back to text-based requirements, which I don't think was a bad thing. Some cases people were still using this to help guide and come up with the designs, but in general we did roll back on that. So it was definitely another learning experience, and it ended up not working out as well for that. So I think that really covers the designs and some experience that I have seen. Really the successful thing that I have seen or I've heard of is there have been some tools out there that do you can generate through model-based development. You can link directly to test cases, and it would actually auto-generate code, or majority of generating the code. So I have heard success. I just personally haven't experienced that. So the next thing I want to talk about a little bit about is reviews. And so this is something that I have found that maybe it's just because how we work. The reviews can be pretty challenging to get complete, I think. Now, setting up the reviews, we've used tools such as SmartBear to where you can like suck in all the code changes or text-based file changes and do reviews, and it's very simple and nice. But trying to rally all the people to complete the reviews, people are usually focused on their own work and not getting the reviews done. So that's something that we might need to consider, making sure that people are trying to help each other out and doing the reviews. I think another thing too is adding too many people onto the reviews. I think it doesn't bring enough focus on making sure to get someone to focus on getting it done. So people might think, oh well, the other person might go and do the review. So I say limiting the number of reviewers to a review definitely be a recommendation. And then setting clear deadlines and focus points as part of that review. I highly recommend using a tool like GitHub or GitLab to do those type of reviews. I know it doesn't work in every case. Like if you want to do PDFs, I don't think it does rendering of PDFs, or maybe even schematics for like electrical engineering and stuff like that. But for software engineering, you should be able to do majority of your work in like GitHub and stuff like that for your reviews. So it does a really nice job too, because then you don't have to like pick the files and know exactly the before version and the after version. GitHub and GitLab kind of automatically does that if you do follow the branching scheme. Another interesting thing that I found on reviews is Google just released their review policy. So I just pull that up real quick. I added the link in here, but they go into this. It's also on GitHub. This is just their web page of it. It's pretty nice, and some things that I've really like is people basically trying to focus on important things like design, functionality, complexity, and that type of stuff, where I have seen a lot of reviews where it was basically like the comments in the review, the code comments maybe aren't quite perfect, or the grammar isn't perfect, so it's not really looking into making sure the code is operating efficiently or better or incorrect or something like that. So that still does happen in the reviews I've seen, but it seems that people tend to focus on, well, I can't really find the problems, so I'm going to scrutinize something like style or something like that. So that's another thing too. I think style really should be enforced by an IDE, not really a human being doing that, because it doesn't really add so much value to the product, working product. So that's something that, at least kind of like my pet peeve, is really style comments should be caught by the IDE, and if the IDE doesn't do it, then maybe you shouldn't really consider that as a guideline or something that you want to check. So just that's another thing too, is in the review, what kind of value is it going to be bringing to the end customer? So I would reiterate that to the people and the reviewers, is to make sure that when you do leave comments, to not limit your comments or anything like that, but to really think about, before you put this comment down, someone else is going to have to review it and dispute it, and is it really worth the time to add that type of comment? So really add in comments to the review that are going to bring value to the end customer, so, or really the product itself. So that's really some ideas or thoughts I had on reviews. Nothing too crazy, but yeah, so limiting the reviewers and setting clear guidelines on what should be done in the review. So all right, I think that should wrap it up for design and reviews. As always, you can contact me at acorbin3@gmail or FAU, or just through YouTube. Feel free to let me know if you have any questions. Thanks.